The reason that elimination works in two variables is because, and I'm just making this up, you don't have to write this, if you have 2x plus 3y equals 15 and 3x minus 3y equals 4, then you can eliminate these y's so that all you have left is x. And you can solve an equation if you just have x's and a number. Like you can figure out what x is. So we're going to be using this idea to help us today with our elimination. We just are going to start with three variables, which means the first thing we have to do is we have to eliminate one variable. So right now we have 3, we're going to get it down to 2. So looking at these three equations, what's going to be easy for us to eliminate? Just looking at those three. And when I say eliminate, we're only going to use 2 of them to eliminate something right now. Z. Okay, I would say z or x. It'd be easy to eliminate z because I have a plus z and a minus z. And then also it'd be easy to eliminate x because I have just x's here, so I could easily just switch some signs and eliminate something. Let's eliminate z. I like that because that's pretty easily set up. So the first thing I'm going to do is we're going to combine. We're going to use these two equations right here, and we are going to eliminate z. Because if I smush them together, then these z's go away. And if I smush my x's together, what do I get? 3x. Okay, so this would be 3x. And then I'm going to do the same thing with my y's. Plus 3y equals 12. Yes, because I'm going to do the same thing with the other side. So over here we have 8 and 4. And if I combine those together, I get equals 12. Okay, so I have a brand new equation. And I'm going to call this equation 4. Why am I calling that equation 4? It's the fourth one. I had 3 that I started with, and now I've made a new one, and this is equation 4. Well, this equation, 3x plus 3y equals 12, that looks like what we had on our homework that was due today. It sure does. So now I need to get another equation that looks like that. So I'm going to do the same idea of elimination. So I'm going to rewrite my systems. You don't have to rewrite your systems. I just mark all over mine, so mine are hard to read. So I'm going to rewrite my system. So I have x plus 2y plus z equals 8. And then I have 2x plus y minus z equals. And then I have x plus y plus 3z equals 7. So now I'm going to do the same process. I need to smush 2 other equations together. Then I can also eliminate z. Well, I've already used the first 2, so I can't use both of those. I have to use the third one this time. So if I wanted to, and since this is so new, we're kind of working through this together. If I wanted to get rid of z in this third equation, which of these other 2 would I combine it with? What would I have to do first, though? I'd have to multiply it by 3. So if I multiplied this entire equation by 3, because we're allowed to do that. We're allowed to do whatever we want as long as we do it to both sides. We talked about that last time. Well, 3 times 2x would be 6x. 3 times y would be 3y. And 3 times negative z would be 3z. And then 3 times 4 is 12. Okay, so if I combine these 2 together, what happens to my 3z and my negative 3z? They cancel. And then what happens to my x and my 6x? What does that give me? 7x. And what happens to my y and my 3y? 4y. And what happens on the other side? I have 7 and 12, so that's going to give me 19. So which equation is this going to be? Equation number what? 5. So we have now created a 5th equation. I know you're like, why does all of this matter? Well, look at our 2 equations that we created. Aren't these 2 equations that we created just like the equations we had on our homework? Yeah, so we know what to do with those. We know that we can eliminate with that. So that's our next step. Okay, y'all are going to have to help me out because I can't see what I have written. So my first equation was what?
3x plus 3y equals 12.
Okay. And my second one was?
7x plus 4y equals 19.
Okay. All right, so again, we're going to use this idea of elimination, and we need to either eliminate my x's or my y's. Think we should eliminate the y's? Okay, so if I wanted to eliminate the y's, what would I have to multiply this first equation by? 4. Okay, so if I did 4 times 3x, that's going to give me 12x. And 4 times 3y is 12y. And 4 times 12 is 48. What would I have to multiply my second equation by? Negative 3. So negative 3 times 7x is negative 21x. Negative 3 times 4y is negative 12y. And negative 3 times 19 is negative 57. So if I look at these two now, what happens to those 12 y's? They cancel. And why do they cancel? They're opposite. One's negative, one's positive. So these 12 y's are going to cancel. And then if I combine that negative 21x and that 12x together, what is 12x minus 21x? Negative 9x. It's okay. And then 48 plus negative 57, or 48 minus 57? Negative 9. And how do you solve that? What do you do? Divide by negative 9 on both sides, and we now know that x equals 1. So because this has 3 variables, that means my answer is an ordered triple. It is an x, a y, and a z. And we have figured out that x is 1. So that's the first thing we've done. So now that I know x, I need to find y and z. And just thinking about what we did before, we're just going to plug it back in. So the question is, do I plug it back into one of my 3 original equations? Or do I plug it into one of my 2 that I created?
The 2 that you created.
Okay. All right. So I can't, and the question was, does it really matter? And I'm going to address that and confirm what you said. I can't plug it back into one of these 3 yet, because if I plug in something for x, how many variables am I still going to have left in this equation? 2. I can't find an answer yet. But if I plug x into one of either this equation, equation 4, or this one, equation 5, well, if I plug it into equation 4, how many variables am I going to have left? 1. I can solve that. I can get an answer for that. So it's a process. We're just working backwards now from what we already had. So I'm going to take, let's see, which equation do you want to plug it into? The first one or the second? Equation 4 or equation 5? That's what I would go with. So equation 4 said 3x plus 3y equals 12. And we've already done all the math, and we know that x is really 1. What is 3 times 1? 3. So 3 plus 3y equals 12. How do I solve this? What do I do? Minus 3 from both sides. And I get that 3y equals 9. And then what do I do to get y by itself? Divide by 3, and I get that y equals 3. So I now have the next part of my answer.
Now you would have to plug it into one of the original equations.
Yep.
Do the first one.
We plug both of them into one of the original equations, and that will give us what? Z. So, because now I know that y is 3. So I need to plug it into one of the first 3 equations. Does it matter which one? No. Same thing as before. It doesn't matter which equation you plug it back into. As long as you do the math correctly, you should end up with the same answer. So it's just literally whichever equation looks easiest to you. I think the first one looks pretty easy, just kind of looking at it. So the first equation said x plus 2y plus z equals 8. So I'm going to write that out. I have x plus 2y plus z equals 8. But we know that x is what? 1. And then y is 3. So plus z equals 8. Well, that's 1 plus 6 plus z. Sorry, let me make sure I cross my z's so they don't look like 2's. Equals 8. What's 1 plus 6? 7. So really I get 7 plus z equals 8. And how do I solve that for z? Minus 7. And I get that z equals 1. How do I find what? Okay, we already have it. Z equals, sorry, positive 1.
So 1, 3, 1.
So I already had x and y. Now I have, oops, sorry. Let me group this better. I apologize. I forget that it does this. Okay. So now I know that z is, 1. So that's my